Hello, welcome to Independent Event Probability Screencast. If two events are independent, the outcome of one has no effect on the outcome of the other. For example, if you have two spinners, the, the outcome of spinning the first spinner has no effect on the outcome of the second spinner. The same way that when you roll a die, it does not have an effect on the outcome of picking a card in a deck of cards. Given the situation of a coin, and we're going to toss this coin 3 times, I'm going to show you a tree diagram to show the different situations. This tree diagram has 3 branches. The first branch represents the first toss, the second branch represents the second toss, and the third branch represents the third toss. As you can see, after tossing the coin 3 times, you have 8 possible outcomes. Head, 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 head and tail, head, tail and head, head, tail and tail, so on and so forth. If we want to find out the probability of getting a head, we know that there are 2 possible outcomes, either getting a head or the tail, and that's 2. And there's only one favorable outcome, and that's getting a head. So we have a probability of 1/2. The same way, the same probability for getting a tail. That's also 1/2. And it is being shown here. It is showed here for each branch. Okay. Now, the sum of the probability for any set of branch or path is always 1. So this 1/2 and 1/2 is 1. Same way here 1. And then 1/2 and 1/2 here for this small branch is also 1. Okay. Now the probability of getting a head and a head. Remember that to find out the probability of an outcome, we multiply the probabilities of all the events along the path. So this is only for 2 tosses, getting a head and a head. For the first toss, it's 1/2, and then the second toss, 1/2. So we have 1/2 times 1/2, we get 1/4. There's 1/4 there. The same probability that you'll get if you have head and tail, tail and head, and tail and tail. If you're looking at this branch or the second toss, if you add all together the probabilities, you'll get 1. So 1/4 plus 1/4 plus 1/4 plus 1/4, you get 4/4. Same way, so let's take a look. The probability of a tail and a head, 1/4. Okay, now, if there's for 3 tosses, what's the probability of getting a head, a tail, and a tail? Okay, the probability is 1/2 here, another 1/2, and then another 1/2. Again, we are going to multiply the probabilities of all the events along the path. So 1/2 times 1/2 times 1/2 is 1/8, so that will be an 8. Okay. Same way for head, head, and head, that will be 1/8. Head, head, and tail, 1/8, and tail, head, head, 1/8, and all the other events there. Okay, once again, let's take a look at the third branch of this tree diagram. If we add all these probabilities, we will have a total of 1. Okay, so what if we're going to try to find the probability of getting 2 heads and 1 tail? We need to look at the different situations or events that we're going to have 2 heads and 1 tail. You could have head, head, and tail. You can also have head, tail, and head, and you can have a tail, head, and head. Okay. For each event or each path, you will have a probability of 1/8. So I'm going to put it there. These are the situations or the paths. Okay, and so each one of them will have 1/8, and you had You have to add them. You'll get 1/8 plus 1/8 plus 1/8, and you'll have 3/8. Okay. So let's try another situation. What if there's a bag A which contains 3 red marbles and 4 blue marbles? Bag B contains 5 red marbles and 3 blue marbles. A marble is taken from each bag in turn. At this time, I would like you to draw the tree diagram. So pause the video and have enough time to draw the tree diagram for this situation. To continue, here's the tree diagram, but I did not put all the results. Okay. We're going to find the missing probabilities for the tree diagram. You should have 2 branches, one for bag A and one for bag B. For bag A, we know that there are a total of 7 for the total possible outcomes because you have 7 marbles for bag A. 3 of them are red, so that for the probability of getting a red, you have 3 out of 7. So for blue, you should have 4 out of 7. Okay. Moving along to bag B. Bag B contains 5 red marbles and 3 blue marbles, so there's a total of 8 marbles inside the bag, so that will be your total number of possible outcomes. For getting a red, there are 5 red marbles, so you have 5 out of 8. So for blue, you'll have 3 out of 8, and then you should copy these probabilities on the second one, 5/8 and 3/8. Okay. First question is, what is the probability of getting a blue marble followed by a red? Pause the video and write your answer. Okay. The answer, please represent this by writing the probability of blue and a red. Blue here has 4 out of 7 probability, and then a red has 5 out of 8. So to find out the probability of an outcome, we multiply the probabilities of all the events along the path. So this path. So 4 out of 7 times 5 out of 8. 8, you'll get 20 56th, or 5 out of 14. Second question. What is the probability of getting a blue marble followed by another blue? Okay. Write your answer in your notebook. Okay. So for blue, you have your blue here, and so this is your path, blue and blue. So 4 out of 7 times 3/8, you have 12 out of 56, or 3/14. Try the others. What's the probability of getting a red and then blue, then red and red? Okay. I hope you have a clear idea of how to get this. Before I see you in class tomorrow, I'd like you to answer this question or these questions to check your understanding. The probability that Alex arrives home on time is 70%, or 0.7. If he does arrive home on time, the probability that his dinner is burnt is 0.1, or 10%. If he does not arrive home on time, the probability that his dinner is burnt is 80%, or 0.8. I'd like to see a tree diagram and answer these 2 questions given to you. I'll see you in class, and we're going to solve this in class.